So good afternoon all. Today we can see uh, start with the second part of our module 2, that is about the physical data organization. So these are the contents of module 3, physical data organization. That is a review of the terms, blocking factor, and next heap files, indexing, different types of indexing, and then about finally we have the structure of B trees and B plus trees. Then extendable hashing and grid files. So in this video, we can see the first two topics, that is about the physical and logical records and the blocking factor. So what is a physical file? So actually the physical file means it is contains the actual data that is stored in the system, and it will be also having the description of how this data is presented and it is received from the program. And they can contain only one record format for more than one or more members. It will be only having a single format only. Physical files will be having only a single format only in physical files. Okay. And in records in database files can be externally, or it can be also have a program described. And the physical file can have a keyed sequence access path. This means that the data can be presented to a program in a sequence based or in the based of some key fields. That is some unique fields. We can have some key unique fields, suppose, for example, based upon the roll number or based upon the first names. So we can order these files, physical files, and we can store it in a drive or something like that. Next one is a logical file. Logical file actually does not contains any data. It will be giving some of the description about the physical files, or the description about the records that is found in the physical file. So it will be presenting the logical view of more than one physical files, and it can have more than one format. So here in physical file, it will be having only a single format, whereas in logical files, it can contain up to about up to 32 formats. It can contain, the logical files can contain. So if your program processes a logical file which contains more than one format record, then you can read a record by record format to set the format you wish to see. Okay, that is, you can also set the format of the physical files that you want to access. So typical database applications needs only a small portion of a database at a time. Okay, so the entire record is not needed. So here, what we are doing is that we will allocate the particular block of data, a portion of the data that is required to access, and that particular portion will be copied to the main memory, and then it will be rewritten to the disk. If some changes have been done, then we will be rewrite this particular block of data back to the disk. Okay, and the data in the disk will be organized in the form of records. So all the files or the data will be stored in the form of records. So what is a record means? The definition for a record is given as: record means it is a collection of data values. Okay, some collection of data values, and it can be interpreted as facts about some common entities or attributes and their relationship. A record means there will be having some relationship or the entities descriptions or attributes. That collection is called as a record. So record can be stored on a disk in a manner that makes it possible to locate them efficiently when they are needed. So next, the file organizations. The file organizations refers to organization of a data of a file into records. We can also divide that particular record into different blocks and some of the access structures. Okay. So what are the different access methods? That is, we can provide some of the group of operations. Some operations can be performed for some files, but we can give some access methods to some files. So we can see some of the access methods. So these are the primary file organization. First one is how these records are accessed or how these physical file records are placed in the disk. These are some of the methods, access methods. The first one is the heap file. So heap file means it is actually a unordered file that there is no particular order, and these files are placed on the records on a disk with no particular order. And after suppose a new file comes or new record comes, it will be appended at the end of the file, so one after the other. Okay, so if a new file comes, that will be appended at the last as the last record of this file. Next one is a sorted file, that is a sequential file. So sequential file means the records will be having some values, or we can select some of the attributes or key values, and based upon this particular key values, we can sort the records. For example, roll number or the first names of this first name of the student. So likewise, we can sort the records based upon some of the key values. Next one is the hash file. So hash file means we can use some of the hash functions, and based upon the hash functions applied to a particular field, we can hash keeper. That is the whatever the hash function that we are applying, that is called as the hash key. And based upon this hash key, we can determine the records placement on the disk. And other different primary file organization is B trees and other tree structures. So already we have studied the structure of the binary trees and tree structures in data structures. So I am not going in detail. Next one is a secondary organization. So secondary organization means it is actually allowing the efficient access of the file or records based upon some of the alternate fields than those have been used in the primary file. So we can have the primary field, that is a primary key or something like that. And also we can have a secondary key also in order to sort or in order to take the data efficiently from the disk. Next one is records and record type. So what is a data? Data means, so what is a record? A collection of related entities or related attributes, we can call it as record. So data actually it is stored in the form of records, and each record will be having some related amount of data values. Uh, that means the entities, the attributes, and their relationships, we can store it as a record. So the record will be having some of the field name, that is the attribute names, column names is the field name, and each field name will be having some of the data type also. That is a whether if you are given the field name name or an ID, the name will be having the data type of or varchar or variable character or a character or a string data type. And for roll number, we can give a integer data type. So each field name will be having a data type, and this will be constituting a record type or a record format definition. So the record type means the formats, the field name and the various data types that in which that record is having. That is called as a record type. So next one is files, fixed length records, and the variable length records. So a file means it is actually a sequence of records. So what is a record? Record is a collection of entities and the relationship or the data together, we can call it as a record. And the file means it is a collection of or sequence of record. So in many cases, all the records in a file are of same record type. That is very important. All the records in a file, in a particular file, all the records that is in a file will be having the same record type. If every record in a file has exactly the same size, then the file is said to be made up of the fixed length records. So if every record in a file is having the same size, the file is said to be a fixed length record. Okay. So if suppose if you have a file and each record in this file is having the same size, then that means it is having a fixed length. And if it is of a different size, that means it is having a variable length records. So here we have this is a structure of a record. So here this is actually the record header, that is the header information. So what will be the length of this record, and from what address this record starts. And these are the data types: gender, birth date, name, address. These are the data types of this particular record is having. Okay, so here also that in suppose we have a table, and the table name is star, and we have the ID integer data type, name as varchar, address as varchar, gender and date of birth. So here if you see the name and address, it is varchar, that is it is having a variable length records. Okay, variable length data type. So records can have a fixed size. That is, the fixed size example is gender and date of birth, date of birth, and the variable length it is having name and address. So the variable length means it can. So here it is represented. The variable length size is up to 255. So here it can accommodate up to 255 characters per address. So this is another representation. So here the three record storage format is given here. So first one is the fixed record, that is name is having a fixed size, then SSN number fixed size. So here from 1 to 31, it will be assigned for name, then SSN number next 9, then the salary, everything is having fixed size. So second format is that a record with the two variable length, that is the salary as well as the job code is a variable, and the other three things, that is the Smith, the SSN number and the computer, will be having the fixed length. So in order to separate the first each characters, we have a separator characters used. That is here the after name the SSN number is coming, right? So here in order to separate these two attributes, we have a separator character. And the third one is that here we have a variable length record with three types of different separator characters. So here this is a variable length, this is also variable length, and this is also variable length. Then we have different types of separator characters. So after the value inside this first cell, then this special character will be used, and then we will be having the second field value. Okay, then the special character is used, then the third field value, which is computer, and we have the this means that the record has come to an end. Character means representation of it terminates a record. So here this is also a representation. Here we have a record, and the fixed length size field is 50 size. Okay, the size fixed length is 50. That is, here this is the record header part. Header we have the information, and this will give you the size of this record. So total 70 is the size of record 1. Okay, size 70. And we have the fixed part is that name, gender, address, and birth date are the fixed part. So name is having the fixed part, gender is having the fixed part. Again, the birth date is also having the fixed part. So here the first 50, so the length of the fixed part is given as 50. So the 50 positions will be occupied by name, gender, and birth date. And next, finally, we have the variable length, variable field, length field, that is a address part. So here the rest, that is after 50, from 51 onwards, the record will be storing the address of this record 1. Okay, the first person. So here for record 2, it will be the size of the record 2 is given as 80, and the 50 position is reserved for the fixed part, fixed size field, and the variable size field is a address. So here in record 2, it is given 30 with the bytes for the address part. Next one is a spanned and the unspanned organization of the data. So here a block means it is a unit of data transfer between the disk and the memory. Okay, so here we can access a block of data. If you want to access, if we want to take a block of data from the disk to memory. So when the block size is larger than the record size, then each block will be containing some n number of records. Okay, and although some files may be unusually large records that cannot fit in one block. So we have two different organizations. So first one is a spanned one. That is, if a record, say a record one, cannot be stored in one single block, that can be splitted into two. That is, the first part it can store in one block, and the rest part in the second one. Okay, and there will be a pointer at the end of this first block. So the block containing the, in order to point to the block containing to the remaining part of the record, and this organization is called a spanned organization. Okay, and the second thing is unspanned, that is the reverse. That is, it will not allow a single record to be spanned in two different blocks. It will allow only a single record in a single block. If there is no space, means it will be taking a new block uh, uh, to be in the uh, next block. So we can see an example. Because if we have five files, if we have five records in a file, R1, R2, R3, R4, and R5, and here it is given it as each record has a size 40. Okay, so here this is 40, 40, everything is 40 size, and each block will be having a size of 100 bytes. So here we have given the block size is 100. So how we can fill this block with the records? Here we have two blocks is that in spanned organization. So we will taking the first record, which is of 40 bytes. It will be allocated in block 1, R2 in also in block 1, and it will be occupying 80 bytes of this block 1, right? This is 40, this is 40, so 80 bytes. Okay, and what about R3? Okay, R3 is also having total size is 40 bytes. Okay, so the 20 bytes of R3 can be stored in this block, and the rest 20 bytes. For that, we can have it in the, we can place that R3 in the second block, block 2. Hmm? So also we need to have a pointer after the R3, end of this block 1, we need to point this pointer to point from this thing to the record R3. Okay, but this organization is called a spanned organization. So after saving this R3, we can continue with the R4 and R5 in the block 2. So it has sufficient space to save the records R4 and R5 also. So what about the unspanned? The same file is given, that is R1, R2, R3, R4, R5, each of size 40, and the block size is given as 100. Then it can store R1 and R2. So when we consider the R3, it requires 40 bytes, right? In order to be in block 1. But there is only 20 bytes per vacant space is there in block 1. So here R3 will not be allocated in block 1. It will be using the block 2. Okay, so here block 2 will be used to block 2, R3 will be using block 2, and next one it will be taking next block, this block 2 will be taking the R4. Here also there will be unused space. Again, the R5 won't be fit in block 2. So here R5 will not be mm, in will not be in block 2. It will be using the next block. That is, block 3 will be taken for R5. Okay. So we can see the disadvantage of using unspanned, right? That is, so many unused spaces are there in different blocks. Okay. So that is the main disadvantage of using unspanned organization. So next about what is the blocking factor of a file. So here the records of a file must be allocated to a disk block because the block is a unit of data. The block means it is a unit of data that will be transferred from disk to memory. Okay. So when the block size is larger than it will be containing more than one records in a block. So here we are given, suppose you are having a block size of capital B bytes and you have a fixed length records of size R. Okay, R is the given size of record and B is the block size. And if B, the size of block will be, if it is larger than or equal to R, then we can say that the block factor, BFR means block factor. So here this block factor is equal to B by R records per block. And what is this L sheet means? It is a seal function. So if you are given a point value, that will be taking the next higher value. Okay. So here BFR means it is called as the blocking factor of a file. So we can see in detail. So here in general, R may not divide B exactly. So we will be having some unused space in each different blocks. So that will be given by capital B, which is the block size, minus BFR into R. Yes, R is the record size. So this is the unused space in each block. So in order to utilize this unused space, we can store some of the records in one block and the second part in the second block. So we have a pointer that is actually we are doing in a spanned organization. Okay. So next one is the variable records using spanned organization. So that we have discussed previously we had discussed about the spanned in about the fixed length. Okay. Next we can see the variable length records using the spanned organization. So here in this each block we store different number of records. In this record, the blocking factor BFR means it is the average number of records per block for the file, and it will be given as f of x. So here x means B is equal to the number of blocks needed for a file for R records is given as R by R is the file of R records and divided by BFR is the blocking factor. Okay. Then BFR represents the average number of records per file. We can see an example. You are given if this is given as the number of records. Here it is the number of records. The record size is 100 bytes. Block size given is 512 byte. For spanned organization, the number of blocks needed is this is 1 lakh into 100 and divided by 512. So where 100 is the record size and 512 is the block size. So here in spanned organization, it requires 19,523. Okay, and this is calculated. When the calculations are done, you will get this result. And for unspanned, so unspanned we have the average block, right? So here the number of blocks per block will be, that is 512 is the block size and 100 is the record size. So 512 divided by 100. So that is around 5.12. So we have to seal using the seal functions next higher value. So 5 records per block. Okay. Then total number of blocks is uh, total number of blocks is 1 lakh divided by 5, therefore it will be 20,000. So here in unspanned it requires additionally it requires 468 disk blocks. Okay, so if you are using spanned, it is having only around 90,500, whereas in unspanned it will be taking 20,000 blocks to save the records in our block. Next question is it is given as how many disks required to store 2000 records each of size 100 bytes. Given block size is 512. So for spanned organization, the number of disk block is equal to 2000 into 100. 2000 is the record size, okay? Number of records, and record size is the 100, and the block size is given as 500. So using the formula, we will get around 390.6 is equal to 391 blocks. Okay. For unspanned organization, number of records per block is 512 divided by 100, which is equal to 5. And number of disks is 2000 divided by 5, which is equal to 400. Again, here for spanned organization, uh, it requires 9 blocks lesser than when compared to the unspanned organization. Next are the different allocation file blocks on different types of methods that file blocks are allocated in a disk. The first one is that contiguous allocation. Contiguous, the meaning itself we can say one by one or consecutive or continuous. Okay. So here in this, the file blocks are allocated in a continuous manner. That is, here we can see here this is the block numbers. That is 0, 1, 2, 3, 4, 5. That's allocated in a continuous manner. Okay. So here if we have n number of blocks in a disk and a file begins with the block at position x, the next block will be assigned to x plus 1, x plus 2, and so on. Okay. So and it is the advantage of using this continuous location is that it is easy to implement the minimum number of seek time. Seek time means the the time taken to access a block. Then the disk movement is minimum. Then the memory access is faster. The sequential, it is actually a sequential and well direct access. And the disadvantage is that the time of creation, the file size must be initialized, and also that as it is pre-initialized, the size cannot increase. Okay. The size is always fixed. You can't increase the size. Next one is the linked association. Linked association, that means the it is not necessary to the files has to be stored in an order. It will be in a scattered manner according to the availability of the space in the disk. And therefore, in order to have the track, there will be some pointers. Okay, so the pointers are used to point to the next block of the same file. So here we have a file 1, start is 0 and 13 is the last number. So file 1 pointers after, so this is the index for file 1. After that, a pointer will be pointing to the next content of this file 1, that is 5. Next content of this file 1 is 10. And next finally we have the last, that is a 30. Okay. So the start and end is also represented in a directory. And this is the memory organization of file 1. Okay. So here the pointers are used to point the next block of the same files. Next, the allocation is the cluster allocation. Actually, cluster allocation means it is a collaboration of the previous, that is a continuous and the linked association. That is, you will be having a clusters, that is a group. Okay. So here the disk clusters of consecutive disk blocks, and these clusters will be linked with the help of a pointers. And these clusters can also called as a file segments or extents. Next one is the indexed allocation. So indexed allocation means, so here also some pointers are used, and these all pointers will be put together in one location, and which is called an index block. So if you have a particular block and the details or the pointers of this particular block, the pointers of that particular block will be stored in one location, and that is called as an index file. Okay, so we will get all the locations of the block in one index file. The blocks and pointers are spread over the memory, and in the link here, if in the case of linked allocation method, the pointers will be it is linked, actually it is linked, but it will be spread all over the memory. Okay, so once we have gone to the first location only, we will be knowing the second location of this file. Okay, so but in this case, we will be knowing every location of this file content. And with this index location, it is easier with the index block to, if you are able to retrieve the index block. So next is the file headers. The file headers means it is a file descriptor. That is, so these are some of the file information about the file or the system programs, what that has to be needed to access the file record. Okay. So here the file header or a file descriptor contains information about the file which is needed by the system calls. The header will be containing the information to determine the disk addresses, the file blocks, as well as the record format descriptions. Okay, it also will be containing the attribute length, the order of the attributes within the record of the fixed length, spanned records, and the field type codes, etc. So if you want to search a record on a disk, we need to take more than one blocks has to be copied to the main memory buffers. Okay, there will be some programs that will be searching for a desired records within this buffers using the information in this file header. And if there is a address of a block that contains the desired record is not known, and the search will be doing the search programs will be doing a linear search one by one. Does we'll be searching for the desired block one by one using the linear search, and this file block will be copied into the buffer and the and searched until this record is located, and the file block have been if it is not retrieved, or if you have not found the particular file, then the search will be completed unsuccessfully. But this is a time consuming for very large file, and our goal is to have a good file organization so that we can locate the desired record with a minimum amount of minimum number of block access or block transfers. So these are the common types of file operations. So first one is the open, that is it make the file ready to access, and it will be associating the file pointers, and it will refers the current file record at each point of time. Next one is the file find function. That is the first file record that satisfies a particular condition, and it will be making that, and it will make the current file as it will be making that file as a current file record. Next one is the current find next. That means it will searching the next file record that satisfy the search condition and makes as the current file record. Next operation is a read operation. The current file record will be read into a program variable. Insert means it will be inserting a new record into a file, and that particular new file will be making as a current file. Next is delete. It removes the current file record from the file, and usually by marking the record to indicate that is it will not be no longer exist or valid. Next is modify. It will be changing some field values and of this current record. Closes, that means it will be terminates if to access to this file. Reorganize means we can the record marked deleted are physically removed from the file, and we can have a new organization of the new file when it is created. Next is read or ordered. So we can order the file blocks in a particular based upon a particular or specific field or an attribute. So that is what we are doing in a read ordered. So next is files of unordered records, that is a heap files. So the records are placed in a file in the order in which they are inserted. So new records are inserted at the end of the file. So this organization is often used with additional access points such as the secondary indexes. So how the insertion is done? That is, inserting a new record is very inefficient. The last disk block of the file is copied into the record, and the new record is added, and the block is then rewritten back if you have made it and the block is rewritten back to the disk. The address of the last file block is kept in the file header. Searching, how you can search for a record. The linear search is done, and searching the linear search, actually it is an expensive procedure. If we are searching for a particular record or search condition, then we can go for we satisfy a search condition. Then on an average, the program read will read into the memory and search half of this file blocks before it finds the record. For a file of B blocks, it requires searching as B by 2 blocks on average. This is in an average case, that is half blocks are searched. If no records or several records satisfy the same condition, then the program must read all the and search all the B blocks in the B number of blocks in the file. Next is deletion. A program must find its block, whatever you need to delete, copy that particular block into the buffer. Okay. Then after copying, you delete that record. So whatever record you are intended to delete that record from the buffer and finally rewrite that particular block back to the disk after the deletion. Okay. So this leaves some of the unused space in the disk block. So once you have deleted that space will be empty, right? So that is what it is mentioned as unused space in the disk block. So after deleting a large number of records in this way, that means you will be having some wastage of storage space. So in order to do the deletion efficiently, we have another technique called, we have a extra byte or a bit called a deletion marker, which is stored along with each record. Okay. So whenever a record is deleted, it will be setting a deletion marker bit. So that is the extra bit along with each record that will be set to a certain particular value. Okay. A different value for this particular marker indicates that it is not deleted or it is valid, and if it then search program will be searching only for a valid record inside this block for this particular extra bit. Search programs will be only looking for this extra bit, whether it is valid or not. So the search will be conducted only inside the records where for it is valid when conducting the search. So both these deletion techniques require some of the periodic reorganization of the file to reclaim the unused space of the deleted records. So once the record is deleted, there should be have some reorganization of the files. Then only that space can be efficiently used. So we can use either a spanned or a unspanned organization for a heap file or unordered file, and it may be used for either a fixed length or a variable length. So modifying a variable length may require us deleting the old record and inserting a modified record, because the modified record may not sometimes fit on the old space. So for if a file is unordered and the fixed length record using the unspanned and the continuous allocation, then it is a straightforward. That is, the file will be numbered in 1, 2, 3, 4, etc. And the block will also be numbered in 1, 2, 3, up to BFR, that is the blocking factor, BFR minus 1, where BFR is the blocking factor. And we can say the ith record of this particular file will be located in I minus BFR. And the I mode BFR will be the I mode BFR record is that particular block. So here that we can access the particular ith record from a particular block. So we can directly or relative direct file access. Such a file is called a relative or a direct file, and because the records can be easily accessed directly with these positions. So here, if you want to access the record number 5, then 5 mode BFR factor will give you the 5th record of that particular block. So it makes the access of these files easier. So next one is the files of ordered record. Ordered means sorted. So previously we were discussing about unordered or heap files. Here it is ordered. So ordered means the records will be ordered on the basis of some key attributes or some field or field values. So here, and it will be ordered or sequential file based upon some of the field. So here you are given an example of an employee records. Here this is a record which is ordered on the basis of their names. So here the first name it is A to C. It is from first name, second letter ordered from around to this thing, it will be down to block 1, the other things block 2, etc. to block 5. So ordering is based upon the key value of the 5. So what is the advantage over the ordered records over unordered records? You have mainly three advantages. The first one is we can read the file in order to we can access it. Read the files in order of the ordering key values. It becomes extremely efficient because no sorting is required. You can directly read the values. Second, if you want to find the next record from the current one, then also with the help of this attribute, this you can find the next attribute. So if it is within the same block, then no need to access the new block also, right? Third one is using the search condition, the ordering key values will be based upon the ordering key values that will be much faster access, and we can use a binary search technique so that it will be taking only less time, okay, so to access the particular record. So ordered files are blocked and stored in the continuous cylinders in order to minimize the safe time. That's the access time. If you have a binary search or a disk file, and it can be done on a blocks rather than on the records. Suppose that the files has the blocks numbered from 1 to etc. up to D, and the records are ordered depending value of their ordering key value. We can search for a record based upon the key value, that is key. So according to the binary search, it will be taking log to the base 2 B blocks, whether the record is found uh, successful search. If it is a successful search, then it will be taking this amount of time, this number of blocks. And on not an improvement over linear search, it will be average is about B by 2 blocks will be accessed when the record is found. And B blocks are accessed when it is not. That is, full blocks has to be searched for an unsuccessful search. Ordering does not provide any advantage for random or ordered access based on the values of the other non-ordering fields. In this case, we need to do the random search, random access for a linear search. We need to do a linear search for random access. To access the records in order to based upon the non-ordering fields, it is necessary to create another sort of copy in a different order of the file. So insertion and deletion records are expensive operations for an ordered file because these records has to be remain physically ordered. Okay, sorting is actually a expensive operation. Uh, so, and after insertion, we need to copy back the records to the previous position. Everything has to be done. So in order to insert a record, we must find the correct position in the file, and based upon this ordering field, we have to make space in this file in order to insert a record in that particular position. So this, if it is a large file, then it is very time consuming, and on an average, half of the records of the file must has to be moved to make space for a new record. And this means that half the file blocks must be rewritten after records are moved among them. For record deletion, the problem is less severe. Deletion markers and the periodic reorganizations are used. These are the average access times, that is for unordered heap. Then we can use the linear search, then we will be taking B by 2. B is the number of blocks. B by 2. Ordered, if you are using a sequential search or a linear search, then it is B by 2. If you are using a binary search, then log B to the base 2 will be the time, access time. Okay. So these are the about the access time. Now we can consider an example. So you are given an unordered file of 1 lakh record with record size of 100 bytes stored in the block of 4096 bytes with an unspanned record organization. Assume that no system relation information stored in the block. On average, how many blocks would be accessed to file a particular record? So you are given the number of blocks, the number of records per block is 4096 divided by 100 will give you the number of record per block. So 40 records will be there in a block. What will be the number of block size? Number of blocks means that is 1 lakh divided by 40. So you have total 2500 blocks. So average number of blocks to access a record is V by 2, right? It is unspanned record organization. So that is V by 2. So 2500 divided by 2 will give you the 1250 block access. So next is consider a sorted file of again it is a 10,000 record with size of 100 bytes stored in a block uh, of 4096 bytes. It is unspanned record organization, and assume that there is no system relation information stored in the block. On an average, how many blocks would the access to find the particular record? A particular record if search is based on an ordering field. So that is here number of records is 40. Number of records per block is 40 records per block, and number of blocks is again 2500. The average number of blocks need to access a record is log B. So where B means is the block size, right? So here log 2500 to the base 2. So that you will get, it will be given as 12 blocks. So with this, we can wind up today's videos. Next, we can see in next portions in next video.